Opus is a lossy audio coding format developed by the Internet Engineering Task Force that is particularly suitable for interactive real-time applications over the Internet. Opus incorporates technology from two other audio coding formats, the speech-oriented CELT and the low-latency CELT. Opus can be adjusted seamlessly between high and low bit rates, and internally, it transitions between linear predictive coding at lower bit rates and transform coding at higher bit rates. Opus has a very low algorithmic delay, which is a necessity for use as part of a low audio latency communication link, which can permit natural conversation, networked music performances, or lip sync at live events. Opus permits trading of quality or bit rate to achieve an even smaller algorithmic delay, down to 5 milliseconds. Its delay is very low compared to well over 100 milliseconds for popular music formats such as MP3, Ogg Vorbis and HE-AAC. Yet Opus performs very competitively with these formats in terms of quality per bit rate. Unlike Ogg Vorbis, Opus does not require the definition of large codebooks for each individual file, making it preferable to Vorbis for short clips of audio. As an open format standardized through RFC 6716, a reference implementation audio codec called Opus Tools is available under the new BSD license. All known software patents which cover Opus are licensed under royalty-free terms. Features: Opus supports constant and variable bit rate encoding from 6 kbits to 510 kbits, frame sizes from 2.5 milliseconds to 60 milliseconds, and certain sampling rates from 8 kHz to 48 kHz. An Opus stream can support up to 255 audio channels, and it allows channel coupling between channels in groups of 2 using mid-side coding. The inherently low delay in Opus makes it possible to be used in the same real-time applications required by telephony, voice over IP and video conferencing. For high-quality audio, the ability to maintain low latency at higher bit rates is made possible by research done by the CELT Foundation on the CELT codec. During any Opus stream, the bitrate, bandwidth, and delay can be changed quickly and seamlessly without introducing any distortion or discontinuity in the audio. As an open standard, the algorithms are openly documented, and a reference implementation is published. Broadsom and the CELT Foundation own software patents on some of the CELT algorithms, and Skype Technologies SA/Microsoft own some on the CELT algorithms. But each has pledged to make them available royalty-free for use with Opus once the format was accepted as an IETF standard. They also reserve the right to make use of their patents to defend against infringement suits of third parties. The applicability of non-royalty-free patent claims from Qualcomm and Huawei to Opus is disputed. The Opus format is based on the low-latency CELT format and the speech-oriented CELT format. The transform layer is based on the modified discrete cosine transform with approaches from CELT. CELT was modified and among other things, support for 20 milliseconds frames was added. The CELT layer that specializes in speech signals is based on linear predictive coding and an optional long-term prediction filter. CELT was modified and among other things, support for 10 milliseconds frames was added. To minimize packet overhead at low bit rates, CELT has support for larger frames of 60 milliseconds. The shared range encoding of both parts of a hybrid stream was taken from CELT. The format has 3 different modes, 2 being for pure speech signals, and a third for general audio. One of the speech modes is capable of reproducing the full spectrum of the human hearing range. In this mode, CELT is used for the upper part of the frequency range, and CELT is used for the lower part. For low bit rates, the upper frequencies can be cut off and the CELT layer left out. For audio at higher bit rates, the CELT layer that specializes in speech signals is left out, and the non-specialized CELT layer is used. The reference implementation is written in C and compiles on hardware architectures with or without a floating point unit, although compiling without floating point support excludes some algorithms that do not currently have a fixed point implementation such as audio bandwidth detection. Containers Opus data can be encapsulated in Ogg containers. The content of such Ogg Opus streams should be specified as audio Ogg. codecs equals Opus, and for Ogg Opus files the Opus file name extension is recommended. Support for encapsulation of Opus in Matroska containers has been completed in CVTool-NIX. WebM specifically enlists support for Opus. Opus is also allowed as a registered format in the MPEGTS and MP4 containers. Sample rates following sample rates are defined in Opus request for comments. History. Opus was proposed for the standardization of a new audio format at the IETF, which was eventually accepted and granted by the Codec Working Group. It is based on two initially separate standard proposals from the Kshift.org Foundation and Skype Technologies SA. Its main developers are Jean-Marc Varlin, Cohen Voss, and Timothy Bieterberry. Among others, Juin-Wei Chen, Gregory Maxwell, and Christopher Montgomery were also involved. The development of the CELT part of the format goes back to thoughts on a successor for Vorbis under the working name Ghost. As a newer speech codec from the Kshift.org Foundation, Opus replaces Kshift's older speech codec Speaks, an earlier project of Jean-Marc Varlin. CELT has been worked on since November 2007. The CELT part has been under development at Skype since January 2007 as the successor of their SVOPC, an internal project to make the company independent from third-party codecs like ISAC and ILBC and respective license payments. In March 2009, Skype suggested the development and standardization of a wideband audio format within the IETF. Nearly a year passed with much debate on the formation of an appropriate working group. Representatives of several companies which were taking part in the standardization of patent-encumbered competing formats stated objections against the start of the standardization process for a royalty-free format. Representatives of Polycom and Eric Zorn the creators and licensors of G719 as well as France Tar Copyright La Copyright.com, Huawei and the Orange Labs, which were involved in the creation of G718. The working group finally formed in February 2010, and even the corresponding study group 16 from the ITUT pledged to support its work. In July 2010, a prototype of a hybrid format was presented that combined the two proposed format candidates Silk and CELT. In September 2010, Opus was submitted to the IETF as proposal for standardization. For a short time the format went under the name of Harmony before it got its present name in October 2010. At the beginning of February 2011, the bitstream format was tentatively frozen, subject to last changes. Near the end of July 2011, Jean-Marc Varlin was hired by the Mozilla Corporation to continue working on Opus. In November 2011, the working group issued the last call for changes on the bitstream format. The bitstream has been frozen since January 8, 2012. On July 2, 2012, Opus was approved by the IETF for standardization. The reference software entered release candidate state on August 8. The final specification was released as RFC 6716 on September 10, 2012 and versions 1.0 and 1.0.1 of the reference implementation were released the day after. On July 11, 2013, Opus 1.0.3 brought bug fixes and a new surround sound API that improves channel allocation and quality, especially for LFE. On December 5, 2013, Opus 1.1 was released, incorporating overall speed improvements and significant encoder quality improvements. Tonality estimation boosts bitrate and quality for previously problematic samples, like harpsichords. Automated speech music detection improves quality in mixed audio. Mid-side stereo reduces the bit rate needs of many songs. Band precision boosting for improved transients. And DC rejection below 3 Hz. 2 new VBR modes were added, unconstrained for more consistent quality, and temporal VBR that boosts louder frames and generally improves quality. On November 26, 2015, Opus 1.1.1 added further optimizations and bug fixes. Quality comparison and low latency performance. Opus has been shown to have excellent quality, and at higher bit rates, it turns out to be competitive with audio formats with much higher delay, such as HE-AAC and Vorbis. In listening tests around 64 kbits, Opus shows superior quality compared to HE-AAC codecs, which have so far been dominant in that area because of their use of the proprietary spectral band replication technology. In listening tests around 96 kbits, Opus shows slightly superior quality compared to AAC, and significantly better quality compared to Vorbis and MP3. Opus has very low algorithmic delay, a necessity for use as part of a low audio latency communication link, which can permit natural conversation, networked music performances, or lip sync at live events. Total algorithmic delay for an audio format is the sum of delays that must be incurred in the encoder and the decoder of a live audio stream regardless of processing speed and transmission speed, such as buffering audio samples into blocks or frames, allowing for window overlap and possibly allowing for noise-shaping look-ahead in a decoder and any other forms of look-ahead, or for an MP3 encoder, the use of bit reservoir. Total one-way latency below 150 milliseconds is the preferred target of most VoIP systems, to enable natural conversation with turn-taking little affected by delay. Musicians typically feel in time with up to around 30 milliseconds audio latency, roughly in accord with the fusion time of the Haas effect, though matching playback delay of each user's own instrument to the round-trip latency can also help. It is suggested for lip sync that around 45 to 100 milliseconds audio latency may be acceptable. Opus permits trading off reduced quality or increased bit rate to achieve an even smaller algorithmic delay. While the reference implementation's default Opus frame is 20.0 milliseconds long, the CELT layer requires a further 5.0 milliseconds look-ahead plus 1.5 milliseconds for resampling, giving a default delay of 26.5 milliseconds. When the CELT layer is active, it requires 2.5 milliseconds look-ahead for window overlap to which a matching delay of 4.0 milliseconds is added by default to synchronize with the CELT layer. If the encoder is instantiated in the special restricted low delay mode, the 4.0 milliseconds matching delay is removed and the CELT layer is disabled, permitting the minimum algorithmic delay of 5.0 milliseconds. Support: the format and algorithms are openly documented and the reference implementation is published as free software. XSHIFT's reference implementation is called Opus Tools, and it consists of a separate encoder and decoder. It is published under the terms of a BSD-like license. It is written in C and can be compiled for hardware architectures with or without a floating point unit. The accompanying diagnostic tool Opus Info reports detailed technical information about Opus files, including information in the standard compliance of the bitstream format. It is based on Ogg Info from the Vorbis tools and therefore unlike the encoder and decoder is available under the terms of version 2 of the GPL. Software equals. Most end-user software relies on multimedia frameworks provided by the operating system. Native Opus codec support is implemented in most major multimedia frameworks for Unix-like operating systems, including Xtrema, FFmpeg and libv libraries. Although Microsoft Windows Direct Show framework lacks an Opus encoder and decoder, such capabilities may be acquired by installing third-party codecs like lavfilters or XSHIFT.org Foundation's Open Codecs. Google's Android supports the Opus audio codec natively since version 5.0. While support in multimedia frameworks automatically enables Opus support in software which is built on top of such frameworks, several applications developers made additional efforts for supporting the Opus audio format in their software. Such support was added to AIMP, Amarok, CMOS, for BAR 2000, MPXPLAY, Music B, SM Player, VLC Media Player, Winamp and XMPLAY audio players. Isocast, Liquid Soap and Airtime audio streaming software. And Asunder Audio CD Ripper, Burnuxp CD Burner, FFmpeg, libv and Media Coder media encoding tools. Streaming Isocast radio trials are live since September 2012 and January 2013. SteamOS uses Opus or Vorbis for streaming audio. Opus support is mandatory for WebRTC implementations. Opus is supported in Mozilla Firefox, Chromium and Google Chrome, Blink-based Opera, as well as all browsers for Unix-like systems relying on Xtrema for multimedia format support. Although Internet Explorer doesn't provide Opus playback natively, support for the format may be added by installing Open Codecs by Shift.org Foundation. Due to its abilities, Opus gained early interest from VoIP software vendors. Several SIP clients, including Acrobit SoftPhone, Briar 10 Lite, CSIP Simple, Empathy, Jitsi, 20, Line 2, Linphone, Phoner and Phoner Lite, SFLPHONE, Mumble and TeamSpeak 3 voice chat software also support Opus. TrueConf supports Opus and its VoIP products. Asterisk lacks built-in Opus support for legal reasons, but third-party patches available for download. Tox P2P video conferencing software uses Opus exclusively for audio encoding-decoding. The Gates Air Intraplex IP Link and T-Line Merlin and Genie families of broadcast IP audio codecs and T-Line Report IT mobile codecs add Opus support to embedded and mobile devices. Digital Radio Mondiale, a digital radio format for AM frequencies can broadcast and receive Opus audio using Dream software-defined radio. The Wikimedia Foundation sponsored a free and open-source online JavaScript Opus encoder for browsers supporting the required HTML5 features. Hardware since version 3.13 Rockbox enables Opus playback on supported portable media players, including some products from the iPod series by Apple, devices made by Arriva, Archos and SanDisk, and on Android devices using Rockbox as an application. Devices based on Google's Android platform, as of version 5.0 Lollipop, support the Opus codecs. Chromecast supports Opus decoding. Grandstream GXV3240 and GXV3275 video IP phones support Opus audio both for encoding and decoding. OBI OB1062, OB1032 and OB1022 IP phones all support Opus. Notes. See also: Comparison of audio coding formats, streaming media. References. External links, official website, Opus on Hydrogen Audio Knowledge Base.